Hello and welcome to the 11th episode in my series on understanding science. Today we're going to be looking at one of the most widely used and effective arguments provided in favour of all manner of pseudoscience and bad ideas. It's a technique so common that you'll probably encounter it almost every day, and I bet you've used it yourself too. In fact, you might not even have considered this as being wrong before. But I'm hoping that after all the previous lectures in this series, it will soon become obvious why this technique is something that we need to avoid in all legitimate logical arguments. Not only that, but we need to learn how to recognise it and counter it in the arguments of others. I'm talking about special pleading. Let's take a look and see what this technique involves. Special pleading is usually the last resort of someone who's lost an argument and refuses to admit it. It's a defence mechanism designed to scrape some vague impression of legitimacy from a failed proposition. In short, special pleading, at least in the sense that we're interested in here as it relates to science and pseudoscience, can be summarised by the phrase, "But what if?" Remember how we learnt in Lecture 10 how anecdotal arguments are the worst kind of evidence, not entirely without any value whatsoever, but certainly no use in establishing a rigorous scientific theory. Special pleading is to arguments what anecdotes are to evidence. Special pleading is what you do when all the legitimate types of argumentation have been lost and you just can't accept that you're wrong. Let me give you an example. For many children in Western countries, losing their baby teeth is not an entirely painful experience because the tradition says that if a child leaves a lost tooth under the pillow overnight, the tooth fairy will come, take the tooth and replace it with money. When I was young it was 10 or 20 pence, but it's obviously substantially more these days. I remember this happening to me as a child and being amazed that the tooth fairy knew that the tooth was hidden under my pillow and somehow managed to replace it with a neatly wrapped coin right under my head without me waking up. Only a magical creature of extraordinary power could possibly have achieved such a remarkable feat. But then, as I grew up, I started to question the story. How could the tooth fairy possibly visit all the thousands of children who would leave a tooth under their pillow that night across the whole world, I wondered. The answer was simple. But what if the tooth fairy has special powers that enable her, or him, to travel very quickly from house to house by waving a magic wand? I wasn't entirely convinced. What does the tooth fairy want with all those teeth anyway? I continued. There's no conceivable use for them. The answer would come back with the familiar phrase, "But what if the tooth fairy uses teeth as part of a recipe for magic fairy dust, which she uses to grant wishes to well-behaved children?" And so it would continue. For every sensible objection there would be some kind of far-fetched answer beginning with, "But what if?" or words to that effect. It's a pattern I would also see happening at Christmas time with Father Christmas. How can he visit all of those children in one night? There's too many of them. But what if he has magic powers and can slow down time? Okay, but how can he fit all those presents in his sack? It would weigh thousands of tons. But what if the sack is magical and contains a portal into another dimension where the presents are kept until he reaches in and picks them out? Okay, how does he get down the chimney? They're far too small, and some houses don't even have a chimney. But what if he uses his magic spells to teleport himself inside the house? Okay, reindeers can't fly. But what if they're special magic reindeers with magic powers that only Father Christmas's reindeers possess? And so on. All of this will be, of course, very familiar to anyone who's read Carl Sagan's fantastic book, Demon Haunted World. In this book, Sagan introduces his own example. He claims that he has a dragon in his garage. For every objection of his unbelieving questioner, he has a ready excuse. The dragon is invisible, which is why you can't see it. The dragon's breath is heatless, so you can't detect it with infrared sensors. The dragon floats, so it leaves no footprints. It's incorporeal, so you can't spray it with paint to reveal it, and so on. I think these three stories are clear examples of special pleading. To spell out at last what I mean by this technique, if it's not already obvious, special pleading can be described like this: introducing an unsupportive, speculative claim in order to justify a theory without any rigorous evidential support. In the realm of pseudoscience, this usually involves inventing some claim that's logically possible but usually extremely unlikely. And of course doing this prevents a pseudoscientific argument from being comprehensively disproved by empirical or logical argumentation. Let's look at some more common examples from the world of pseudoscience to see exactly what I mean. For many years, perhaps centuries, skeptics have been challenging pseudoscientists and paranormal proponents to show some evidence for their extraordinary claims. Those paranormal claimants have repeatedly and spectacularly failed, of course, and so science has continued to dismiss all supernatural claims as likely false. We covered much of this in Lecture 10, in which I investigated the supernatural, but I didn't look into the excuses that supernatural claimants use to explain why the tests that scientists conduct always fail. When there are so many vast prizes on offer, not to mention the extraordinary fame and recognition that could be obtained by anyone proving a supernatural claim to be true, it seems fairly damning that no such proof has ever appeared. The problem, so the claimants say, is that the supernatural is a fickle thing, and the presence of negative energy emitted by skeptics is enough to make the supernatural effect go away. This is, of course, an example of special pleading. Let's put it in the familiar framework that we've seen so far. The scientific tester begins. So I've just completed a test of your psychic abilities, sir, and you haven't performed any better than chance. Because of this, I conclude that you have not provided me with any convincing evidence to show that you have any psychic abilities whatsoever. And the claimant responds, but what if your negative beliefs disrupted the psychic energies and prohibited me from performing as well as I usually do? I maintain that I do have psychic abilities, but they just can't be tested by unbelievers. This claim is, of course, utterly hollow. The burden of proof is now on the claimant to show that the psychic powers are indeed inhibited by the presence of a skeptic. Presumably they could measure the psychic's abilities with a range of people in the same room and not tell the psychic which ones are skeptics and which ones are believers. Then see if the results differ. During this test, anyone not directly involved in it should be watching remotely from a distant location. After this test, when the results are again completely negative, the conversation would usually go something like this. So, we completed the second test in which we varied the presence and absence of skeptics, unknown to you, and yet again you haven't performed above random chance. So I maintain my belief that you are not able to demonstrate any psychic abilities. Comes the reply, but what if the mere fact that this test is designed and run by skeptics is enough to make it fail? What if the psychic realm is aware of the intention of those carrying out the research and disrupts my energies so that my psychic abilities can never be measured for the purpose of providing proof? What if psychic abilities only work if people have a blind, unevidenced faith that they will work, but if they were ever proved to be true using rigorous methods, then they would go away? And so on. Anyone who's ever worked with pseudoscientific or paranormal claimants will be more than familiar with all of these arguments and the to and fro of the repeated special pleading and failed testing that inevitably happens. My second favourite response is to say that I could now conduct a test on historical cases of psychics who are not, at the time, being tested. If I collected results from those psychics' historical predictions and then analysed them now to see if they achieved anything supernatural, then presumably this would count as a test of supernatural powers that could indeed, were it positive, prove those powers to exist, which means that predictions performed 20 or 30 or 40 years ago would have to perform no better than chance at the time, because the spirit realm would presumably know that in several decades' time someone, i.e. me, would be examining those predictions in an attempt to check whether they were real or not. Which of course leads to my number one favourite response. Given that everyone today has a video phone, then essentially any supernatural claim could be recorded and verified were it true, which means that all psychic claimants nowadays can only possibly perform the same as chance. Or else, if they did something amazing and it got recorded, then that would provide evidence for skeptics to use in their investigations. So by the psychic's own claims, no psychic power could possibly work anymore. One of the most illustrative examples of a supernatural claim that follows exactly these lines is something that you may be very familiar with, and I'll cover that next. Dowsing is the process of trying to locate a particular substance, usually water, at a range or through material which blocks every known mechanism for detecting it. You will almost certainly have seen dowsers using some combination of twigs or bent metal rods, holding them loosely in their hands and attempting to locate water underground perhaps by watching for when those dowsing rods, apparently without any human intervention whatsoever, suddenly flick around or point downwards towards the ground. It's a skill that the dowsers will be absolutely and genuinely convinced that they can perform. I think this is actually one of those examples where the vast majority of those who claim a supernatural power are actually genuinely convinced that they can do it. They're not frauds, they're just unaware of a particular quirk of the human nervous system, and then confirmation bias does the rest. So, how does dowsing work? Or rather, how do the dowsers claim that it works? Well, here it becomes very hazy. Most descriptions from dowsers revolve around the dowser somehow becoming in tune with the target substance in some way, often referencing vibrations or energy fields or other terms which don't really mean what dowsers think they mean. What's really going on is, as some of you may know, something called the ideomotor effect. This is an incredibly convincing self-delusion, where you can subconsciously cause a physical effect without consciously believing you're doing so. Usually this occurs because you set up a system which responds in a large and obvious way to a very small difference in inputs, so tiny subconscious alteration of the dowser's hands can actually cause really dramatic swings of the dowsing rods that they're holding. And the dowser's not even aware that they've caused this effect, because the movement they made was almost certainly very small and entirely unconscious. The same effect is claimed to be responsible for the phenomenon of Ouija boards, spelling out messages from the spirit world. As with dowsers, once you blindfold the participants, then the mysterious supernatural power predictably goes away entirely. Many rigorous studies have been carried out to determine whether or not dowsers can actually do what they claim to be able to do, however it might actually work. It won't surprise you to learn that these studies have all proved to be entirely negative. The dowsers, when tested under controlled conditions, never perform better than chance. And dowsing is something that is remarkably easy to test under rigorous controlled conditions. For example, take 10 opaque bottles, fill one with water, place them before the dowser, and ask them to detect which bottle contains water. If you tell the dowser which one it is, then they'll always confirm that the water is easy to detect using their dowsing method of choice. They'll get it every single time. However, once they're unaware which bottle contains the water, the dowser will pick the wrong bottle 9 times out of 10, which is exactly what you expect by chance. But this is where the special pleading comes in. But what if my powers only work on running water? They'll begin. Well, the powers worked perfectly well before, when they knew which bottle contained water, but whatever, let's give them the benefit of the doubt. So the scientist sets up an even more complex situation, with pipes buried underground out of sight and taps that can turn the water on or off through one of those pipes, which will be chosen randomly and without the knowledge of the dowser. The dowser then has to detect which pipe has water running through it. Again, if they're told which one it is to calibrate their skills, then they succeed 100% of the time or thereabouts. But as soon as they're unaware which pipe contains water, then their skill completely goes away. Tests of this nature have been performed many times with the same predictable results every time. And of course, the special pleading continues. But what if my powers only work with natural water, not water that is inside artificial pipes? But what if I was just having a bad day? But what if there were too many sunspots that negatively affected my abilities? That one was actually used by a dowser in one test. And of course, the standard pseudoscientist get-out clause. But what if my powers don't work in the presence of skeptics? All your negative energy is just disrupting the vibrations. In one very important and well-known test in 1980, carried out by the paranormal investigator James Randi and the Australian Skeptics Organisation, all the dowsers signed up front that the test was a fair test of their abilities, and they all predicted that they would get over 90% accuracy on such a test. And all of them verified that their powers were indeed working when they were aware of the location of the substance they were attempting to locate. Yet when tested on an unknown target, the accuracy plummeted to just 13%, which is well within the expectations of random chance. Yet after this test, all of the dowsers continued to believe in their abilities. They'd all rationalised away their failure by special pleading. To them, the anecdotal evidence that they gathered over the years overruled the more rigorous scientific evidence collected by the test. This is an excellent example of what I mentioned in the previous lecture. Anecdotal evidence is often worse than useless and cannot be used to determine the truth of scientific claims, no matter how much of it you may have. The masters of special pleading are probably the young Earth creationists. This group of people believe that the Earth is less than 10,000 years old and was created by a god or gods according to the story they read in their holy book. Christian young earthers are probably the most prominent, with them believing that the story laid out in the book of Genesis in the Old Testament of the Christian Bible is actually a factual description of the early universe. Needless to say, their claim goes against pretty much all of modern science and common sense, so it's not very long before they end up resorting to special pleading to make their arguments work. I don't have time to cover all the arguments they use of this nature, there's thousands of them, and they add new ones every day. But the most important one probably relates to a technique used to date the Earth. One of the most prominent sources of evidence proving that the Earth is roughly 4.6 billion years old is radiometric dating. This is a highly technical process which involves studying certain radioactive substances, and by looking at the ratios of their different isotopes and knowing the rate at which those substances decay, you can tell how old the sample is. The standard young Earth response is to special plead this away. Firstly, but what if the original ratio was different in the past to how it is now? Well, that's an easy one to discard. Whereas the techniques for radiometric dating that we might learn in high school are susceptible to this problem, and these are usually the only ones that the creationists know. The more cutting-edge techniques, however, simply don't work that way, and they don't need to know the initial ratio of these isotopes. So it doesn't matter whether they were different or not in the past. However, once you point that out, then the creationists come up with the biggest special pleading of all. But what if the rate of decay of those isotopes has changed over time? They provide no evidence for this whatsoever, of course. There are a few examples for varying decay rates of a few substances, but they're very rare, and these aren't the ones we measure, obviously, because we know that their decay rates aren't constant. And also, for any variation, it's never anything like the degree that would be required to make the creationists' numbers add up, and it never happens under the conditions to which these substances have actually been exposed in the real world. So this second special pleading actually turns into a related third one. But what if the intrinsic rate of radiometric decay was different in the past? They're basically saying, but what if the laws of physics are not constant in time? Well, that's an extraordinary claim, of course, and they offer no evidence for it, so we can dismiss it without further consideration. Though, were we to require any further evidence, we could look at astronomy. If the decay rate of substances changed over time, or if the laws of physics changed over time, then we would notice this in the spectra of distant stars. Remember, in astronomy, because of the finite speed of light, looking at distant objects means looking back in time. And we can look at objects that are billions of light years away, and hence we're seeing them as they were billions of years ago. And by looking at the spectra, which means looking at the different wavelengths of light and how much of each one there is, we can tell a lot about the physics of what's going on inside each star. And of course, stars a long way away appear to be following exactly the same laws of physics that we see today. What the creationists are doing here is saying, okay, so according to everything science has discovered today, our claim is massively wrong by almost a factor of 1,000,000, but we believe that the laws of physics are spectacularly wrong to such a degree and equally in such a wide range of different areas that it exactly cancels this out. And that is more plausible than the possibility that we're just mistaken. I used to argue with young Earth creationists, but once arguments like this came up I began to realise that they're simply not interfacing with reality, and I was wasting my time. Science is great if you want to know what's really true, but not so useful if you've already decided that beforehand. Another area where special pleading is rife is the conspiracy theory. There are, of course, many of these, and I've covered the idea of conspiracy theories before in an earlier lecture. In short, I think they're all wrong. Not that there are no conspiracies, of course, but they're usually very short-lived, small-scale and rapidly uncovered. For a conspiracy theory, what must be true is that there's a much larger conspiracy going on, with evidence that's obvious enough for a few amateurs to comprehend, but which, for some reason, nobody else seems to have noticed. No law enforcement professionals from any country or any international organisation, no intelligence agencies from any country, no news organisations. Conspiracy theories are caused by one thing only: the desire for people to have excitement and meaning in their lives, and you can hardly blame them for that. But when this desire finds itself in a particularly paranoid or inquisitive individual without a background in critical thinking, then a conspiracy theory inevitably results. Anyway, let's look at the most famous conspiracy theory of recent times, the 9/11 deniers. This group of people honestly believed that the terrorist attacks on September the 11th, 2001 in the US were not the action of a small group of fanatical religious extremists, but were in fact a giant conspiracy orchestrated by powers unknown, possibly the US government itself. They have a few arguments that they use to back up their claims, mostly so-called anomaly hunting. This technique can be summarized by the phrase, "Here's something that looks strange and I don't understand it, therefore something dark and mysterious must be going on." An example argument against a conspiracy theory might be to consider who needs to be in on the whole thing. So if the government orchestrated 9/11, then for one, a large number of prominent politicians would have found out about it, surely. "Ah," begins the conspiracy theorist, "but what if they were in on it too?" Okay, you continue. Then there's the actual hijackers, actual known members of a known terrorist organisation who were also known to be on each plane that crashed. Coincidence? Ah, but what if the FBI deliberately placed those terrorists on those planes as an alibi? Okay, you have to look at the people responsible for allegedly rigging the entire World Trade Center with explosives, the security staff who must have been aware of this, the people who supplied the tools, the explosives, the detonators, and so on. Then there's the investigators who scoured the wreckage of the towers and claimed that there was no evidence of explosives, and so on and so on. Not a single person suspected foul play and reported their findings to the authorities. Ah, but what if they were all in on it too? Okay. So then you need the agents tasked with capturing the aircraft and those responsible for training them, setting up their backstories, hiding their plans. You need thousands of people who are in on the conspiracy, and not a single one of them has ever come clean, not even on their deathbeds. Not a single document from the Snowden archives, the Edward Snowden archives that were released a few years ago. Not one of them mentioned it. Not a single leak from anywhere in the government has ever proved this theory to be true. Really? Ah, begins the conspiracy theorist predictably. But what if the conspiracy goes even higher? What if the law enforcement agencies and intelligence agencies are all in on it and they're all suppressing or killing anyone who tries to confess? And so on and so on and so on. Special pleading in layers upon layers. There's nothing you can do to argue against this except to say, okay, interesting theory, prove it. Until you find any convincing evidence, I'll provisionally reject it. Of course there's no evidence, they say, because all the evidence has been suppressed by the powers that be. In fact, the actual fact that there is no evidence for this theory is, in fact, evidence for this theory. At which point, like with the Creationists before, I can only advise that you smile politely and walk away calmly and don't turn back. So how do we respond to special pleading? I think it's clear from the more extreme examples of this what's wrong with the special pleading argument. It can be used only to avoid a complete logical impossibility, but has no value other than that. Just because you can rescue your claim from complete impossibility by using special pleading doesn't mean that your claim is now plausible or worth taking seriously. Let's say I meet someone who claims they have a device that can generate infinite free energy. Plenty of people have claimed this over the years, even though, according to the laws of physics, this is totally impossible. But that doesn't stop this one person from claiming that they somehow achieved this miracle using magnets or because of quantum mechanics. You know, the usual hand-waving smokescreens that pseudoscientists habitually employ. Now, in this case, I might say to such a claimant, you can't have a free energy machine because the laws of physics prohibit it. To which they might reply, but I found a loophole in the laws of physics which means that I can generate free energy under a specific set of circumstances. Well, let's pause at this point. Do you find that response convincing? I'd like to hope that you don't, because this person has just made an extraordinary claim, one with a very low Bayesian prior, without providing any evidence whatsoever that it might be true. They've attempted to escape from the physical impossibility of their device by something similar to the "but what if" tactic. The correct response to this statement would be, okay, so let's see some extraordinarily good evidence for your claim, or else I will continue to conclude that it's false. The Bayesian prior, by which I mean, if you remember from earlier lectures, the probability that you would give to this claim before looking at any new evidence. The Bayesian prior for free energy machines is microscopically small, so the evidence had better be undeniable to outweigh this. What has the free energy proponent actually done here, on a deep level? Well, they're essentially saying, you think you've disproved my claim, but you haven't logically disproved it. You've only empirically disproved it. And as long as that's the case, then there's always a logical possibility that my claim could be true. Science, if you remember, doesn't usually deal with logical 100% watertight conclusions. It deals with the spectrum of certainty. Even the most established theories are not 100% unavoidably totally logically analytically true. They're empirically true, meaning that the amount of evidence piled up in favour of them is so vast that it's practically inconceivable that the claim could be false. But as long as something isn't logically proved to be true, then that means that there's always a tiny slither of chance. There's always a logically possible way in which the claim could be false. That's essentially the definition of not logically proven to be true. My opponent here, the free energy proponent, was essentially saying, you haven't logically proved the laws of physics true. They're just empirically proven, which means that there is a logical possibility that they could be wrong. I found such a logical possibility, and it turns out to be true. Now, this logically possible disproof is not necessarily likely or even testable, but that doesn't matter because it's enough to leave a tiny slither of possibility open, and that's usually all the pseudoscientist requires. The human mind doesn't deal very well with instinctively understanding probability and tends to deal with unlikely claims with a risk-reward bias. A claim might be microscopically unlikely, but if the consequences are extremely severe, then somehow the human mind sort of conflates these two things and imagines that the probability is actually much higher, high enough to worry about perhaps. Or if you flip it over, you have things like lotteries, where a microscopically small chance of winning, which is something like 1 in 14 million in the UK, is somehow mixed up with the vast jackpot that you might win, and consequently people believe that it could be me. Mathematically true, I suppose, but so unlikely you shouldn't take it seriously. So to summarise this slide, the first thing we need to realise whenever someone is using special pleading is that all they're really arguing for is the logical possibility of their claim. In almost all cases, this is used as a last resort for a claim that has been empirically disproven, meaning that it's already very far over to the probably untrue end of the spectrum of certainty. The trick with special pleading is to confuse the listener about this and to make them think that not only have you rescued your claim from disproof, but you've actually put forward a convincing argument for its truth, which simply isn't the case. There are infinitely many claims that are logically possible, but to show that such a claim is true is significantly more difficult than proving that it's just possible. One objection that you could raise to this line of argument is simply to say that scientists do this too. After all, you don't have to read too much popular cosmology to come to the conclusion that cosmologists really don't have a clue what happened at the very beginning of the universe. There are a great deal of models, of course, and different groups are looking into different scenarios using a wide range of techniques, almost all of which are purely mathematical, because testing the early universe is simply too difficult for us right now. Most of the fundamental claims that theoretical physics makes about this extraordinarily complex time are simply unproven speculation. They're essentially running the "but what if" gambit. So why is this acceptable? Well, if you remember at the beginning of this lecture, I compared special pleading to the use of anecdotal evidence. And I didn't say that anecdotal evidence is entirely useless, just that it can't be used with any reliability to place a theory on the spectrum of certainty. Anecdotal evidence can still point us in interesting directions, but it's always trumped by any other evidence of a more reliable type that might be found. So with special pleading, there are some cases when it's all we've got. We only have speculation and logical possibilities, and we don't yet have any way to distinguish between them with any reliability. Very early universe cosmology is probably an example of this. We really don't have any agreed models for what happens to the laws of physics when energies get exceptionally high and spatial scales get extremely small. All we have are logical possibilities, and scientists are attempting to build those out into coherent, testable scientific theories. But what we have now, at least for this slither of time in the first tiny fraction of a second of our universe, isn't really a scientific theory. Perhaps some cosmologists will disagree with me angrily about this, but they're wrong. Sure, they're following the scientific method, but until or unless there is a theory that is mathematically coherent and makes predictions that can be tested and has passed those same tests, then what they have isn't a scientific theory, it's just a hypothesis. So why is this scenario different from the ideas we've been discussing so far in this lecture? Special pleading is wrong when a claim defended only by special pleading is compared favourably against another theory that has a much higher standard of support. In these cases, the competing theory with a better standard of support must always win, until or unless the speculations put forward in favour of its opposition by special pleading can actually be confirmed by proper investigation. So if my opponent from the previous slide claims that he's discovered a free energy machine, we know that there is a solid physical law that proves this to be impossible. And we also know that it's very easy for an individual to accidentally introduce measurement errors into an experiment, say, or to get the data analysis wrong, or, frankly, to lie. All of those are vastly more plausible than the special pleading answer, and they're all backed up by mountains of evidence, not just the evidence in favour of the laws of physics as they stand, but also the evidence that people regularly get experiments wrong, and people regularly make elementary mistakes in mathematics. Plus, it's hardly controversial to suggest that people occasionally lie. In this situation, let's say we restrict our explanation for the free energy claim to these four possibilities. Possibility 1, measurement error. Possibility 2, analysis error. Possibility 3, dishonesty. Or possibility 4, genuine free energy. The first three of these are all plausible, in agreement with the laws of physics and evidenced by multiple examples in the real world. The fourth example goes against the laws of physics and requires special pleading to support it. Therefore, it stands at a significantly lower level of plausibility than the first three, and can justifiably be rejected until or unless some high-quality evidence comes to light that supports this claim made using special pleading. Let me try another example which might make it clearer. If you were a detective investigating some grisly murder, your first task might be to gather whatever evidence you could find, and then begin to follow leads to search for the murderer. But if there were no evidence that you could gather, if the murderer had hid their tracks extremely well, then all you would be left with would be speculation. What if it were a relative? What if it were a burglar? What if it were a work colleague, perhaps? All of these claims would make implications, of course. We have evidence for none of them, but they do suggest ways in which we could investigate each possibility, and those might lead us to rule out some of those lines of inquiry. That's a situation where we might perfectly legitimately want to use speculation, because there isn't any other route to take. However, let's say we investigate another murder, and in this case the dead man's next-door neighbour was known to be his worst enemy, and had already threatened to kill him. The murder weapon was a knife which came from the neighbour's kitchen and was covered in the neighbour's fingerprints. The neighbour's footprints were all over the garden and his clothes were blood-stained with the victim's blood. And there's TV footage showing the neighbour entering the murder location just before the murder happened, carrying a knife. The scream is heard and the neighbour's seen leaving in a hurry immediately afterwards. Look, I think that could be considered a fairly straightforward case, and the lead detective would definitely be justified in making an arrest there and then. But if someone else stepped forward and said, "I believe the victim was killed by Elvis Presley," then the detective would be justified in dismissing that claim immediately because, well, for one thing, Elvis is dead. Ah, the claimant continues, but what if Elvis didn't die, but was replaced by an imposter who was killed in his place? Then the government bribed all the doctors who did his post-mortem, and Elvis has in fact been living in a secret bunker in the Pentagon since that day. I think it's fair to say that this claim is logically possible, I suppose, but that's about as far as its plausibility goes. Does the introduction of this argument help the case of the mysterious new claimant? Does it make the likelihood that Elvis committed the murder any higher? I would argue that it doesn't. All they've essentially done is said, well, my claim isn't logically totally impossible. But it should be obvious that we still have no obligation whatsoever to investigate it any further, because this claim remains staggeringly unlikely. Special pleading is basically saying, but here's a thing that is logically possible. To which the correct response should always be, so what? Prove it. Let's summarise what we've learned. Special pleading involves introducing a claim without any evidential support in order to support some hypothesis. Usually this is after the hypothesis has been comprehensively disproved by a more rigorous scientific investigation. Special pleading isn't entirely logically invalid, it's just the worst possible kind of valid argument that exists. Special pleading is basically just saying, my hypothesis isn't logically impossible because of X. The trick with this technique is when the more devious debater uses special pleading as if it somehow confers some new kind of legitimacy to the argument being defended. That is, as if it somehow increases the probability of the hypothesis. This technique is used all the time from all manner of supernatural and factually incorrect claims. Whenever someone introduces an unproven speculation into a debate as if it's a truth, then you need to be aware that what they're doing is special pleading, and according to what you've learned in this lecture, it should be easy to counter. One last point. It's important that you don't fall for this trap yourself. If you find yourself in a position where your argument seems to be under threat, then the honest response should always be, I don't know why. I don't know why this is. Perhaps I'm wrong. I'll take a look at it and get back to you. And then you have to do the thing that so few people have the courage to do. To go and look for what's true, not what's comforting or familiar, but what is actually real. And if that truth disagrees with your beliefs, and you think it's important to deal with the real world instead of fantasies, then you need to discard those old beliefs. It's an extraordinarily hard thing to do, and it takes a lot of courage, but it's what the honest scientific skeptic should always do when faced with the news that they've been wrong about something. The assumption behind all of these lectures, in fact behind the scientific endeavour entirely, is that it's always better to believe as many truths as possible and as few falsehoods as possible. I've argued before that this is a sensible way to approach the world, but I think by this point, if you disagree with that motivation, then I think we probably have to part ways. Ultimately, when dealing with any physical claim, you need to look at the evidence being presented in its favour. Special pleading introduces no new evidence, so it cannot influence the likelihood that the hypothesis it's attempting to defend is true, except to prevent it from reaching absolutely zero. Don't be confused by the distinction between possible and probable, and make sure that you don't try to confuse others either. Well, that's the end of this lecture. I hope you found it useful. If you enjoy these lectures and you think you know other people who may benefit from learning more about science, then please spread the word and get them out to as many people as possible. Next time I'll be talking about another tactic often used by pseudoscientists to attempt to justify their unscientific positions. It's called the Galileo Gambit, and it has interesting implications for how science deals with novel ideas. Is science closed-minded? Is science always opposed to change? Is it rational to relax our stance on evidence to give new ideas a chance? All of this will be covered in the 12th lecture in the series in a few weeks' time. Until then, thanks very much for your time, and I'll see you again soon.